Greetings everyone. Time to talk about completing the square. This is a method that's going to come up a few different times in algebra. And the first time it comes up is when we want to start solving quadratic equations with this particular method. Okay, so let's go into the purposes that we even have completing the square method to begin with. Okay, we've talked about, and either in the class with me or with another class, whatever, you at some point talked about solving a quadratic with factoring. Okay, so solving the quadratic with factoring is all about just breaking it into its factors, and then if it's equal to 0, you can split them and solve each piece. The problem with the factoring method is that not everything is factorable, like the things that are prime. Okay, so that's sort of the beginning motivation there. Now, the way this thing works is I'm going to try and turn a quadratic from something that has a two variable issue into something that has a single variable issue. And when I say two variables, I really just mean two occurrences of x, right? So for example, I have an x squared and I have an x. In solving those quadratic equations, there's no way to just combine those, so that's the real issue, right? So if I'm completing the square, all right, the idea is that I want to factor something perfectly. And when I say factor perfectly, I mean that when you factor it, you get two of the same factor, which causes you to have that thing squared. Okay? There are different stages of things that factor here in quadratics. You can have things that are already perfectly factorable, like x squared plus 6 plus 9 factors into x plus 3, because 3 plus 3 is 6 and 3 times 3 is 9. But since they're the same thing, I can write it as x plus 3 squared. That's a perfect square trinomial. You can have the kind of quadratic trinomials that just factor, right? Like for example here, x squared plus 6x plus 8 is x plus 4 times x plus 2, because 4 plus 2 is 6 and 4 times 2 is 8. And then lastly, you can also have the ones that are flat out just not factorable at all, and that's because there are not two numbers that add to 6 and multiply to 20, for example. Okay? Now what I want you to notice in these three different setups that I have here is that they all start with the same two terms, x squared plus 6, x squared plus 6, x squared plus 6. The only thing that keeps changing is the number, right? That's important to note. Just by changing the n number, you can have something that's either not factorable all the way through being factorable all the way up to perfectly factorable, just by having a different number on the end. So that's what we're going to kind of use to our advantage here, okay? Completing the square is a step-by-step process where I can take any quadratic and then turn it into something that has a perfectly squareable, or perfectly factorable portion. Okay? So let's take those latter two pieces that we were talking about just a second ago, and let's actually go through and complete the square on them just to get this first example out and rolling for you. And then we'll do some examples of actually using this to solve with. Okay, so right here, all we're going to do is completing the square, not the actual solving portion. And you'll notice why that's true. We don't actually have equations to solve here. These are just expressions. Completing the square is something that you can do just to an expression, but you can also do it inside of equations to the expressions in those as well. Okay, so step-by-step process, all right? I'll go through the steps as I do them to this expression here. Separate the number portion away from the rest, okay? So what does that mean here? The number portion is the 8. Remember we were showing you earlier that changing that number can make all the difference in making it a perfect square. Okay, so here I go. I'm going to separate it. And what that just means is I'm going to put a big gap right here. I'm going to put a big gap in between the 6x and the 8 there. The 8 is really along for the ride now. This is the main meat of what I'm going to be factoring here, and I just need to quote-unquote fix it to make it a perfect square. Okay? Step 2, set up the next step. I know we haven't completed this step, but you go ahead and set up the next step because these two are going to actually feed off of each other. Okay? So next, what I do is I'll go ahead and put some equal signs here. The next step starts like this. Because what I'm about to do is I'm about to put a number here that makes this perfectly factorable. So I'm setting up that perfect factorization square of two of the same thing. Okay? So I'm setting that up. Now, how do I feed into it? Step 3, take half of the middle value. It's the b, or whatever you want to call the number in front of x. I'm going to take half of this number, whatever it happens to be. Half. So in this case, half of the positive 6 is plus 3. Okay? Now notice I'm feeding that into the parentheses, right? Because if I do x plus 3 times x plus 3, I'm going to get x squared plus 6x and then plus another number. The other number is the thing that I need over here. And here's how we always find that, right? I square that half value, okay? So next, what happens is I take this number, the 3, and I square it. So right here I'm going to have plus 9. Now I can't just add a 9 in there when there wasn't one there before. That's not valid algebra, right? So instead, what I'm going to do is I'm going to put the plus 9 there, and at the very same time, I'm going to also put a minus 9 right next to it. So technically, I've added 0 value to the whole thing, right? This is a 0 value. But the 3 pieces that I need to factor, because that's the next step, right? After I square the half value and add and subtract that value, right? That's step 5. The next step, the last step, is to factor and finish up. Well, what do I mean by that? If you look at these 3 pieces right here, that perfectly factors into x plus 3 squared. So these 3 pieces right here are already in the next step. It's already done. Yes. So the only thing left to do, finish up, is combine any pieces that are not in that. Okay? So negative 9 plus 8 gives me a negative 1. Okay? So let me rewrite this. X squared plus 6x plus 8. If I complete the square, right? What I get is x plus 3 squared minus 1. Okay? That's what you want. I want something that goes from 2 occurrences of x down to a single occurrence of x. That's what completing the square truly is doing for us here. Okay? Let's do it again on the next one over here. This one wasn't even factorable before, right? So, step 1 was to separate it out. So I've got x squared plus 6x, and then I'll put my plus 20 way over here. I'll set up my next step, which is to put the parentheses with the square. Then I take half of the 6, I square it, I balance it, plus 9 minus 9. These 3 pieces right here are already factored in the next step. There they are. So the only thing that's left is negative 9 plus 20, right? Plus 11. There is my completed square expression. It is 100% equal to the original x squared plus 6x plus 20. It's in a new format now that has less occurrences of x. Now let's do 2 examples where I'm using completing the square to actually go all the way through and solve an equation. Okay? So notice the difference, right? I've actually got the equal sign this time, which means I am solving. I'm going to get x by itself eventually. Okay? Since it's a quadratic, maybe it has two answers. Maybe it has one answer, right? We know that that's possible with quadratics. Well, let's find out. To complete the square, I'm just going to take everything that's not the x squared and the x and just separate it out. If it's extra numbers, equal signs, whatever. Don't change the order or anything. I'm not, doing the left and right side moving type of stuff. All I'm doing is separating. Making that gap. So x squared plus 8x gap equals 1. Right? Step 1. Step 2, write that next step. So x with a parentheses and a squared. And then these two are going to feed off of each other, right? Okay. Half of 8 is 4. And then 4 squared is 16. But remember, I can't just do that. I've also got to do minus 16 right next to it. All right. These three pieces right here, right? These three pieces, that factors into x plus 4 times x plus 4, or x plus 4 squared. So that's already taken care of. That's already here in the next step. Right? Well, I still have a minus 16 here, and equals to 1. So look at where we're at. I now have an equation that just has one x in it. All I have to do is start unwrapping the present, right? Peeling one piece off at a time until x is by itself. And then I can say that it's solved, or at least have values to test. All right, so first, I'm going to add the 16 to both sides. So I have x plus 4 squared is equal to 17. Then, to undo a square, I'm going to square root. Don't forget, if you introduce the square root to the party, he brings buddies with him to crash the party. Square roots always do that. They're radical guys, right? They always bring buddies with them to crash the party. So what I mean is plus and minus. If you introduce the radical, he brings buddies. Plus and minus square root of 17. Well, at this point, simplify the square root of 17 as best as you can. In this case, 17 is prime, so I won't be doing any simplifying. And I have one step left to get x by itself. I'll be subtracting 4. Now I can't bring the 4 into the radical, so the only way to simplify that is just to write it negative 4 plus or minus square root of 17. Don't forget, the plus and minus means that there's actually two different equations that I'm solving at this point. Two different solutions here. I'm getting negative 4 plus the square root of 17 and negative 4 minus the square root of 17. And then depending on your application or the instructions of whatever you're doing, you can either leave them in that format or you may have to punch them in a calculator to get the decimal approximation. Right? Just depends on whatever the instructions are, what you're dealing with. Okay, let's try again. Right here. Y squared minus 5y plus 2 equals 0. Step 1, separate it out. Y squared minus 5y, separate, plus 2 equals 0. Set up the next step. That's going to be a y, not an x, because we're not doing x, inside of a parentheses squared, right? Okay. Then we need to start feeding off of the pieces here. I need to take half of 5. Well, one way to do that would be to use fractions. Another way would be to use decimals. I prefer fractions. The reason is because later on when we're dealing with the radicals, the fractions can be easier to deal with the radicals if you don't happen to have a calculator with you. Okay? Anytime you want to take half of something, you can double its denominator. Technically 5 is over 1 right here. So if I want to take half of it, I would just write 5 over 2. If it had been something like 5 over 7, then I would have written 5 over 14, right? Anytime you double a denominator, you're taking half of the value. Okay, so that's the half, right? That was the half. Now the square, right? To square a fraction is also pretty straightforward. You're just going to square the numerator and denominator separately, right? So to square it, I'm going to get 5 squared is 25, and 2 squared is 4. All right? But just like before, I can't just add the number. I have to also balance it out. And I'm going to subtract 25 over 4 right next to it. Well, the good news of this is like the next step is to factor and finish, right? Remember, these 3 pieces right here are already in the next step. That's what this factoring is right here. Okay? So this is already accounted for. But I still have minus 25 over 4 plus 2. So minus 25 over 4. And instead of plus 2, I'm going to put plus 8 over 4. And that's because I do want to combine these. I need a common denominator to do that, right? 2 is the same thing as 8 divided by 4. And now they have a common 4 denominator. Okay, so I'm simplifying here. Y minus 5 over 2 squared. And then I'll have negative 17 over 4. And it's still equal to 0. Okay, so at this point, I have finished completing the square. Now I'm going to move on to solving for y. So I'm just going to, like I said before, just start unwrapping the present. Peel one piece at a time. I'm going to add the 17 over 4 to both sides. 17 over 4 plus 0 is still 17 over 4. Okay. Next, I'm going to square root both sides to get rid of the square, right? And since I'm introducing the radical to the party, don't forget he brings his buddies plus and minus to crash the party. So I'm left with y minus 5 over 2 is equal to plus or minus. Now I'm going to actually simplify this radical. I can say square root of 17 and square root of 4. But I can do square root of 4, right? That's just 2. All right. One more step, right? To get y by itself, I'll have to add the 5 over 2 to both sides. They already have a common denominator, okay? So I could also say, or 5 plus or minus the square root of 17 over 2, like this. Either one of these is a perfectly acceptable answer. Typically, this is the more common way that we see it written. And again, don't forget, it's actually 2 separate answers. 5 plus the square root of 17 over 2, 5 minus the square root of 17 over 2. And you may or may not have to plug them in to find the decimals. In fact, let's practice that, right? Get out your handy dandy time saver and practice with me here. 5 plus square root of 17, enter, divide by 2. I have 4.56. Or 5 minus square root of 17 over 2, 0.44. And you'll notice I put the approximately sign right there on the y because I did have to chop these decimals to write them. You're not going to be able to write the exact form any other way other than with the radical. Okay? All right, let's do one more example using this method, and let's just go all out, right? Let's have a couple of different things going on here. Notice I do have an extra number in front of my squared there, right? That I'll have to handle. And then I'll also still have to complete the square. And the reason for that is because this is not factorable. And don't forget our original motivation. Not everything is factorable, so I can't always use that factoring method to solve the quadratic, okay? So in this one, right, same idea, it's not factorable, so I need this other method in order to actually solve the quadratic, okay? Now completing the square is going to have to take place inside of a bubble, if you will, because of that 5. I'll show you exactly what I mean, okay? Step 1 is still to separate it out. Let's do that. Okay? Now, in this one, in order to make this factor the way we've been doing it, I don't want this 5 in front of the x squared. What that means is I need to factor it out like this. Normal GCF factoring. Okay. So notice I still have my gap, and notice I put the parentheses way over there to finish my bubble that I was talking about earlier, right? The worst thing that can happen here, by the way, is that 10 wouldn't be nicely divisible by 5 to give me this 2. I could have had something else here like 11 or 12, in which case you could end up with a fraction right here. That's probably the worst thing that can happen. It's not actually that terrible. It's a little bit daunting to look at, but it can happen. Okay? But here's how we work this. I factor the 5 out and then forget about everything else. Just focus right here, the x squared minus 2x, because that's what I'm completing the square on. Focus on this, and you'll notice it's not any different than what we were just doing. I've just got other stuff to take care of later. Okay? So here we go. Set up the quote-unquote next step. I've got my parentheses x and a squared, right? Okay. So there's my next step. Half of the negative 2 is negative 1, right? So I take half. Then I square. Negative 1 squared is plus 1. But of course I can't just put plus 1. I have to balance it out with a minus 1. All right. So the good news is I've already got my factoring done right here, right? These 3 pieces are already accounted for right here. Okay? So let's finish filling out the next step. The 5 has to still be here. And what I'm actually doing is I'm going to distribute the 5, not to everything, but look, if I put the 5 here, right? This 5 is now times all of these 3 because that's this piece. These 3 is the same as this piece here. So I've done 5 times these, right? But then the 1 is still in that parentheses, in that bubble. Technically it's 5 times negative 1, which is negative 5. Then the plus 2 is still there. Then my equals 0 is still there. Okay? Now take a second to make sure you saw what I just did. I did actually distribute the 5, right? I distributed it by chunks. I distributed the 5 times this, that's right here. And I distributed the 5 times the negative 1, that's right here. Okay, so it's all still there. Okay, so I simplify here. I've got minus 3 equals to 0, right? Okay, so that's completing the square in this case. So we're done with that phase. It is a completed square, has the single variable. Now I want to go through and solve it. So let's bring it up here and do that. I've got 5 x minus 1 squared minus 3 equals 0. So I'm going to start by adding the 3 to both sides. And 0 plus 3 is still 3. Next, I'm going to divide by 5. Like so. All right, now I'm going to square root. And don't forget, when I introduce the radical to the party, he brings buddies, because he's crashing the party. He's going to bring plus and minus with him. Okay, so I have x minus 1 is equal to plus and minus the square root of 3/5. Okay, now if you think back to some of the radical things that we talked about, we don't really like to write radicals in this form. In fact, I would like to have my denominator rationalized, right? So I'm gonna do a little work on this piece right here for just a moment, right? The square root of 3/5 is the same thing as the square root of 3 over the square root of 5. Okay, well from there, the square root of 3 over the square root of 5, I'm going to multiply numerator and denominator by square root of 5. Right? That was our technique for rationalizing the denominator. So what do I end up with? Square root of 15 over square root of 25, which is just 5. So that's what I want to bring over here to this one. So what I have is x minus 1 is equal to plus or minus square root of 15 over 5. And that's so that I can write with common denominators more easily and things like that. I'm going to add the 1 over. So I've got, whoops, nope, that's not equal. Don't do that. I've got x equals, adding the 1 over, 1 plus or minus square root of 15 over 5. Okay? This is completely acceptable as an answer depending on your instructions and things like that. Just in case, let's talk about the alternate form. One other thing that I could do here is write 1 as 5 over 5. And then now that they have a common denominator, I can say that x is equal to 5 plus or minus the square root of 15 over 5. Okay? And don't forget, that's still 2 answers, right? 2 solutions. Okay? I hope this helps you in your endeavor to learn the skill of completing the square solving quadratics.